Welcome to qnawire.
In problem 118, we are asked to find the center of gravity of this scratch awl, where we have a plastic handle and a steel shank. And we'll do that using the equation where the centroid times the weight of the entire object is equal to the sum of the centroid times the weight of each component. I'll break it into a few components here where we have a hemisphere of the plastic base, a cylinder in the plastic base. We have a cylindrical hole where the steel shank is going into. So that'll be part 3. And then the fourth component will be the steel cylinder from the shank. And then part 5, component 5, will be the cone at the end of the shank. And the first step will be to find the weight of each component, which will multiply the volume times density to get the weight. And the volume of a hemisphere is 2/3 times pi times its radius cubed, and then we multiply it by the density of plastic. And the radius of the handle is 0.0125 meters. I converted from millimeters to meters so that it'll cancel with the density, which is given in meters. And that density is 1,030 kilograms per meter cubed for plastic, or at least this plastic given in the problem. That comes out to 4,213 kilograms. For a cylinder, the volume is the area of a circle, pi r squared, times the length of the cylinder. And then again, we'll multiply by the density of plastic to get the weight. It has the same radius given in the problem. The length is 80 millimeters, or 0.08 meters. And again, we'll multiply by the density of plastic. We get, this time, 40,450 kilograms, which makes sense because it's a much larger piece than the hemisphere. Now the cylindrical hole is going to be negative because we're subtracting this weight from the total. So use the same equation for the cylinder. And the density here, this is important, is actually plastic, not steel, because the hole, we're removing plastic from the entire plastic cylinder in component 2. The radius of the hole is quite small at 0.00175 meters. The hole is 0.05 meters in length. We get a negative 0.4955 kilograms. Now the steel cylinder uses the same equation, but this time with the density of steel. 0.14 meters long. The density of steel is 7,860 kilograms per meter cubed. You get 10,590 kilograms for the weight of the steel cylinder. Then we have the steel cone or blade at the end. And the volume of a cone is pi over 3 times its radius squared times the height of the cone, or in this case could be considered the length of the cone since it's laying on its side. And this is also made of steel, so multiplied by the density of steel. Cone is 0.01 meters in height. We get 252.1 kilograms. Now we'll also need the sum for the equation I listed at the beginning of the weight for the right side of that equation. 55,000 kilograms. The last part we need for our equation are the centroids of each component. For the hemisphere, the centroid of a hemisphere is 5/8 times its radius, which comes out to 7.813 millimeters. I'm using millimeters in this case because we want the final answer in millimeters. The plastic cylinder is 12.5 millimeters past the hemisphere, plus 40 millimeters to get to the middle of that plastic cylinder or its centroid. The cylindrical hole, similarly, we have to go to the base of the hole, which is 92.5 millimeters from the base of the handle. Then we subtract, well, actually this will be to the end of the hole, and then we subtract half of the hole's length to get its center or centroid. To get to the end of the steel cylinder, it's 182.5 millimeters. And then subtracting half of the steel cylinder, we get its centroid of 112.5 millimeters. The steel cone, we can use the same 182.5 millimeters to get to the base of the cone. And then the centroid of a cone is its height divided by 4. Its height in this case is 10 millimeters. So plugging that in, we get 185 millimeters. Now we know enough to solve the equation. We solve for the total weight to be 55,010 kilograms. And then we can just sum together this table multiplied by the first table of weights, which comes out to this value. And that's the weight, kilograms, times the centroid of each component, millimeters. And so the kilograms cancel, and we're left with the centroid as 61.1 millimeters from the base of the handle.